Alright, so what we're going to do in this video is just kind of go back over all the basic ideas from linear modeling so that we're ready for our test, which is coming up. So we're going to start with doing a best fitting line, and we're going to talk about this with both a calculator and without a calculator. So if I don't have a calculator and I'm given a graph with a bunch of data points and a line that goes through some of them but probably not all of them, then I know that in order to write the equation of this line, I'm going to need to figure out the slope and the y-intercept. Now the way that I'm going to do that is look for what points actually are on the line, and I'm going to use those to help find these values. So the first thing I like to do is go through and circle the points that are actually on the line so that I can make sure that I look specifically at those ones and not the ones that are just there but not actually on the line. So if I look at those points and I go from here to here, I'm going to rise to run 1. So my slope would be 2 over 1, which is 2. Now my y-intercept would be where I cross the actual y-axis, which is at the 3. And if I combine that information into an equation, I would get y equals 2x plus 3 as my final answer, and I'm done. Now if I have a bunch of data, like in this table, but I don't have a graph, what I'm going to do is use my calculator to get that data. So I'm going to go to Stat, Edit, and I'm going to go to the top and clear enter both of my lists. Now list number 1 is going to be the x values. So 30, 31, 33, too many threes, 30, 25, and 18. And list number 2 is going to be 14, 13, 13, 11, 7, and 5. Now I'm going to go to Stat, Calculate, Option 4. I'm going to hit Enter a bunch of times, and I'm going to get y equals, and I'm going to round nicely. So 0.61, but the 9 is big enough to bump that up, so I'm going to put 0.62x minus 6 and then the 3 is not big enough to bump up the 5, so I'm going to leave it as 0.75. And I'm done. Now, let's say I give you a word problem like this one. So it says a truck rental company rents a moving truck for 1 day by charging $29 plus 20 cents per mile. Write a linear model that relates the cost in dollars of renting the truck to the number of miles driven. The first step would be always to define your variables. Whether it says to do that in the problem or not, you should always start with that because it's important to know what your variables stand for. So it says in the problem that the cost in dollars is going to be called C. So C equals the cost in dollars, and X is going to be the number of miles driven. Now when I write the equation, I'm going to use those variables, plus I'm going to look for a number that repeats and a number that's a one-time thing, an initial amount. So C equals, now the number that repeats here is the 0.20, because that's going to repeat every mile. So 0.20, and X is the number of miles, plus the $29 is going to be a one-time fee. Next, I'm going to be asked to use this equation to make some predictions. So it says find the cost of driving 110 miles. Now 110 is a number of miles, and in this problem the x values are the numbers of miles. So this would be an x value, which means I would write C equals 0.20, and instead of the x I would fill in 110 plus 29. Now if I figure that out on my calculator, I would have 0.20 times 110 plus 29, and I would get 51 for my number of dollars that would cost me. In part D it says if you had $300 to spend, how far could you drive? Because $300 is a cost, it's going to be a y value, because in this problem, the number of dollars is the C. So I'm going to write 300 equals 0.20x plus 29, and I'm going to solve this equation. So I would subtract the 29 on both sides, I would get 271 equals 0.20x, and then I would divide. 271 divided by 0.2 would be 1,355 equals x, and since, you can't see, and since x is the number of miles, I would write miles here. Okay, let's try one where we have to use our calculator to get our equation before we can do our calculations. So this says the table below shows the relationship between calories and fat in various fast food restaurants. So x is going to be the number of calories, y is going to be the amount of fat. Because x is always my first row and y is always my second row. Now our first step is always define our variables. Whether it says to do it in the problem or not, we need to start with that. So x is going to be the number of calories, and y is going to be the amount of fat, which is going to be measured in grams. Next, we're going to get our linear model. So to do that, because we have a bunch of data, we're going to go to Stat, Edit, we're going to clear, enter both of our lists that are here, and we're going to type in 720, 530, 510, 500, 305, 410, 440, 320, 598 into the first row, or first column, and then 46, 30, 27, 26, 13, 20, 25, 13, and 26 into the second column. Then we're going to go to Stat, Calculate, Option 4, Enter, 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 and we're going to get y equals, now I'm going to round this nicely, so 0.7, and the 1 is not big enough to change the 7, 0.07x minus 9.26, but the 8 is big enough to bump that up, so I'm going to change it to 9.27. Now once I have that equation all figured out, I'm going to go ahead and figure out how much fat you would expect a 400 calorie burger to have. Now in this problem, the calories is the x. So since this says 400 calories, this would be an x value, which means I'm going to plug it into my equation instead of the x. So I'm going to have y equals 0.07 times 400 minus 9.27. And if I type that into my calculator, I get, 0.07 times 400 minus 9.27, 18.73. And since fat here is measured in grams, I would put grams for my units on my answer. Now if it says how many calories would you expect a sandwich with 40 grams of fat to have? So 40 grams of fat would be a y value because in this problem the fat is the y values. So I would substitute that for my y and I would say 40 equals 0.07x minus 9.27. I would add 9.27 on both sides and I would get 49.27 equals 0.07x. Then I would divide by 0.07 and I would get x equals 49.27 divided by 0.07 gives me 703.86 calories. Okay. That's the end of our review of linear modeling. Now your test is going to have this stuff on it plus all of the stuff from the beginning of the chapter. So it's going to be very important that you do your review and you ask questions and you check your answers. I will see you guys tomorrow for some additional practice. Thank you so much for watching and have a great afternoon.